got to. So I'm going to record this with the stuff that I want to highlight so that Will, Alicia, and Lauren get this bit as well. So using the sample space without any formulae. Yeah, sometimes it's just easier to go back to the sample space. So I'm going to put on there, as soon as this erases for me, I think I've got some background processes going on that are making my machine stop and think about it every 5 minutes or so. Yeah. I appreciate your help there, bro. It's like, oh, I'm feeling a bit sick. You should get that fixed. Thank you.
You should probably start trying to fix everybody.
What's it? I suffer from depression. You should be happier. Thank you. I think my wife might be cheating on me. You should stop her from doing that.
Stop thinking about it.
Yeah, maybe be more attractive. That'd be great. So I'm just waiting for you guys to write it down. That's why there's a bit of a pause in the recording. But I'm going to continue on now because we're going to start example 27. You guys will catch up. So what we've got here is Yannick and Oscar can't agree which movie to watch. So they play a game throwing 2 dice because they are nerds. I love them. If the sum is 7 or 8, Yannick chooses the movie. If the sum is 9, 10, 11, or 12, Oscar chooses the movie. If the sum is less than 10, they throw again. Who has the higher probability of choosing the movie? So we've got Yannick and we've got Oscar. So if you go back to the sample space, you can actually start looking at it and go, okay, well, let's do Yannick's ones, okay? So if the sum is 7 or 8, so sum is 7, sum is 8, sum is 7, yeah? Sum is 7 there, sum is 7 there, sum is 8, sum is 8, sum is 7, sum is 7, sum is 8, sum is 8. You agree? Okay. Then we go, okay, well, what about the grouch? 9, 10, or 11, or 12. So there's a 12. That apparently is going to just highlight them all for me anyway. So apparently it's all them. We agree? Cool. And if it's less than that, we don't do it. So let's go. Okay, well, probability for Yannick is what?
11 out of 36.
So 11 out of 21. And probability of Oscar. Why is it 21? Yep, it's 10 out of 21. Okay. So what we're doing, because we're not worried, even though there are 36 different possible opportunities, we've restricted the sample space. We did this a while back. In this one, we've restricted the sample space to saying it's got to be 7 or more. So the other ones we ditched. So that's why our sample space is 21, not 36. Cool with that? All right. So who has the higher probability of choosing the movie? Yannick. Cool. You all happy with that? Can you guys just remember when you're doing something like that? Oh, there goes the screen. When you're doing something like that, it's important that you actually write down a finishing statement saying Yannick has the Yannick. All right. So that was example 27. You know what that means? Well, before I hang up from this particular phone call, I'm actually going to talk about this last final note, and that way we are completely done. Just to open that up again so you guys can actually see what I'm doing. Connecting? Yep, good. All right, so a final note about general sample spaces. All right, there's 4 results. that we can summarize it. This one. I'm going to get you to write all them down, by the way. So those ones. The probability of not A is equal to 1 minus the probability of A. That's the complement. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Yeah? So that one is all of them, but you've got to subtract the intersection because otherwise you end up counting them twice. Okay? So that's the union. And the other one is the intersection. Next one, probability of A. What's that pipe B mean? So this one, probability of A. It's not nor. Or was that one? It's not an and is intersection. So it's the. Yeah. Probability of A if event B occurs is probability of the intersection of A and B. So that's A and B divided by the probability of B. Now, if you switch those round to have probability of B if A occurred, then the numerator would be the same, but the denominator would be probability of A. Okay? So whichever one is second is the divisor, is the denominator. All good with that? And last one, probability of AB equals probability of A times probability of B, but only if they're independent events.
So I'd like to say if only,
If and only if. You know how you can write if and only if, and you will see this occasionally? If and only if. Like that. An if with two F's. It's an emphatic if.
doesn't it just mean the same if you just don't have that if?
No. Technically, there is a difference. We'll get to that, trust me. All right, so the 4 results were all developed using equally likely possible outcomes. Now, this means that it has to be, okay, 4 results were all developed using equally likely possible outcomes. I'm highlighting that first sentence. Okay, which means there is a finite sample space that is uniform. The 4 results, however, hold in all theories of probability. Okay, so this is one of those cases where we've proven it in a particular case. It's kind of like saying that the area of a square is the sides multiplied by each other, or the area of a rectangle is the sides multiplied by each other, because 2 times 2 is 4, or 2 times 3 is 6, and this one's 6. So we've proved it in one particular case, which is the finite one. However, it holds true in all other theories of probability. You all good with that? So you can prove it using different methods, or we can just do them as axioms and go, well, we know this is right. But it holds true in all the other different forms.